Alright, hello, and welcome to another Incast live stream. I just noticed that the background lighting is not ideal. Let me just try and tweak that a bit. There we go. A bit more light, that's probably gonna help out. Alright, so last week I went over Incast OS, which is something I've been spending a bit of time on here and there, trying to put kind of the whole story together. But for this week, taking a bit of a step back from that, given that there is an Incast release coming out next week. So looking at doing Incast 6.5 next week, and there are a few things still yet to be done on there. Some easier than others. I'm gonna try and sort out one of those features today. So just looking at the milestone here and kind of what we're looking at doing by the 6.5 release. Well, there are a couple of bugs. One that's related to VM disk hot plug. Didn't get to look into that one yet. Hopefully it should be a pretty easy fix. So there's nothing really ever easy with hot plug and PCIe slots and all that kind of logic. But I hope that this is just a pretty straightforward bug and can fix it and be done. Then we've got a huge one. Yeah, pretty major feature. It's gonna be the automatic live migration to rebalance cluster, or at least the initial version of that. I still need to spend a bunch of time on that to actually get it done. We've got a lot of the logic in place through the placement scriptlet we've got, through the automatic healing we've got. So we've got a bunch of that stuff, but we effectively need to now put a way to put a timer on, which then effectively looks at the different servers, figures out which ones are the most loaded, and kind of starts rebalancing things a bit. So that's the idea. We'll see kind of what I end up doing there. One of the ideas would be to effectively have a balancing scriptlet similar to a placement scriptlet, which then lets you really kind of customize, what VMs should be moved and to where, so that this can effectively be done with a lot more customizability in mind. But good to see kind of what direction we're going and how much is gonna make it in 6.5. It's that kind of thing, kind of similar to the automatic healing, where it takes a few releases to really nail it. Then we've got supporting for creating LVM cluster pools through the API. So instead of, so currently effectively need the LVM, the VG to already be created and shared correctly, and then Incast consumes that. So the idea here is to actually do the VG create call for you, effectively providing, there's not that much you need to actually provide for this. It's effectively the name of the block device that you expect to see. But it can be a bit different system to system, so we'd obviously prefer people use the dev disk by ID type thing to select the disk that they want, and then initialize that, and then pick it up on all the machines. So that shouldn't be too bad. It's going to make it possible to start creating LVM clustered pools through things like, or purely through the API, and eventually through the web UI as well. Next up, kind of related still, is the ability to configure the LVM metadata size. That's something I've noticed recently when doing some pretty significant skill testing of Incast. We're running around 16,000 logical volumes on the same LVM pool. And one of the issues there was with scaling there was just the size of the metadata, where by default, I think there's a 10 megabytes limit, which you run out of after around 1500 LVs or so. So having the ability to set a different value would be good, because it's not something you can change after the fact. So it's effectively a creation time property that would be present on LVM and LVM clustered pools. Then the thing we'll actually work on today. So that's the ability to automatically restart failed instances. The failed part there is going to be a bit of a tricky one, because we don't actually know when something is failed, but we can detect some stuff. So like a clean, a user requested shutdown from the API, that we can detect and not automatically restart. But if the container or even VM stops for any other reason, we can't really tell and we'll just bring it back up, which is probably fine for now, but something we might want to improve in the future. Then there's an issue that's being currently worked on by a community member, which is to just better handle situations where you're using Incus user for unprivileged Incus access, but the user's project was deleted for a reason or another, while the user credentials have not been deleted. And that causes a weird scenario where it's failing to connect and doesn't recreate the project, so there's some issues there. And lastly, just a bit of documentation that needs updating for handling of cluster group renames and the impact that has on projects. So that's for 6.5. Expected release Thursday next week. So got slightly less than a week to go for this, and a few issues that need to be completed here. So as mentioned, the focus for today is going to be the ability to automatically restart failed instances. We're gonna probably go. Well, why is it taking so long to load? That's weird. It's GitHub misbehaving again. Happens sometimes. Anyway, so the idea with that one is ideally we'd want something similar to Docker and other platforms where it's possible to have an automatic back off type mechanism where if the instance fails, it automatically gets restarted immediately. Then the next time we wait, wait a bit longer, but also count and allow for like up to 10 restarts within like a 1 minute period or something like that. We'll see how fancy we get. I know there's a few Go packages we can use to do that kind of back off mechanism. But I also don't really want to put in new dependencies necessarily, so we'll see if we end up actually using any of that. Or just doing something pretty simple and hand-rolled. Okay, what's going on with the network here? Is it my network in general being messed up? Looks like it is. Okay. Yeah, this is weird. Okay. Gonna be slightly problematic. Let's see. Just checking the terminal on the side. Okay, it might just be DNS misbehaving, because it's always DNS, isn't it? Okay. Okay. We're still down, yeah. Not quite sure why exactly. Well, let's do a bit of debugging then, I guess. I'll just try to figure out what's going on. Okay, well, I just started working now. Is DNS in general fixed? Maybe. All right, anyway, fixed enough for now. Okay, cool. Yeah, so that's the issue we've got open here for the automatic restart of failed instances. And there was a suggestion to try and look at what's done for K8s, where indeed it does. In this case, it's capped at 5 minutes with an exponential back-off delay. I think for us, for now, I might just do something easier with probably just 1 minute time span from first restart to last. So you've got one, like within 1 minute, you get up to, well, let's put it as like 10 restarts or something like that. And that should be good enough. I do think we will move to something fancier, especially if we see that being a problem with a lot of containers restarting constantly. But luckily for us, most people don't run only OCI containers on Incus. They run VMs and system containers, and those have never needed automatic restart of any kind. So let me check just something real quick. So I've got the code, I've got an up-to-date copy of the Incus code here. Okay. I think there's the network issue was impacting some of my home stuff too, because I just got a notification that there's someone at the door, even though there isn't. So that's like the camera reconnecting or the doorbell reconnecting. Anyways, let's just assume everything is fine. And And let's go look at how to do this. The nice thing with that kind of logic is that we don't actually need to make it OCI container specific. So I can actually use normal incus containers, which are slightly easier for me to deal with. Just go switch to the demo project. If I've got one, I don't remember. I do. And it's got some stuff in it. We don't actually need any of that stuff. I'm just cleaning things up here. And then gonna repopulate with just like one container and then start playing with that for that feature. Okay, let me look at the profile. Okay, default storage, default network, nothing too special, it's fine. And do we have any thing that needs to be deleted there? Yeah, there is. Okay, so all clean. And let's go and launch a container. Okay. So for now, what we'll do is just gonna put a extra Boolean config for that. So as usual with a new feature in Incus, I'm gonna start with an API extension. So let's do API extensions and go locate a new one. Instance auto restart. This introduces a new boot.auto restart configuration key, which when set to true will have the container, the instance automatically be restarted upon exit, upon this unexpected exit. Unexpected exit for up to 10 times over a 1 minute period. So just kind of as the initial logic. So that's the API extensions, instance auto restart, and then need to add that to the list of strings here. Okay. So same thing, instance auto restart. Cool. And actually commit the new API extensions. Extension to restart. Here we go. Okay, next we need to actually add the config key. So for that, it's going to be an internal instance, I think, because it's an instance config key. Internal instance config, perhaps. Yes. So boot auto start is here, and we literally want a boot.auto restart. So I'm just going to copy this section because it's going to be very similar. Go up here, and this is boot.auto restart. If set to true, what's the description? If set to false, okay, that's fine. If set to true, we'll attempt up to 10 restarts over a 1 minute period. Is that what I put in here? Yeah. 10 restarts over a 1 minute period upon unexpected instance exit. Okay. Boolean whether to automatically restart an instance on unexpected exit. Okay. The key is a Boolean, an optional Boolean, so that's fine. Auto restart. Okay, so that will allow us to actually have the config key we can set. So let's commit that. This is incusd instance. Add boot.auto restart. And then let's generate the metadata for the API description and for the documentation. So that's just a generated commit. Okay, there we go. So it just generated those two changes here. And then I need to use the stop, the usual commit message for that. Doc update metadata. Here we go. And if we actually build this now, that will get us an Incus version that has that config key be valid. We'll be able to set it. It won't do anything, but we'll be able to set it. And then we'll just need to do the plumbing to actually have it do something. So yeah, if I go down here and apply it on my system, I'll then be able to do set boot auto restart true. There we go. So it is 9D in the config for that container. It just doesn't do anything useful. So it's up here. Now I'm going to look at doing the wiring for container first, and then we'll look at virtual machines later. But for containers, the wiring for this is going to be internal server instance drivers, driver, LXC. And in here, we've got a function, I believe it's called onStop. Yeah, but not capital. Also, not sure why VI is having a bad day with the syntax aligning. And let's just scroll through things a bit and try looking it up again. Come on, please be nice. Where is that function? Here. No, onStop NS is not the right one. We want onStop. There. So this is called as a post-stop action, and effectively, yeah, it's what's called whenever the instance terminates for one reason or another. We can figure out why to an extent, so there's a target info, and we can also check if there's an existing operation effectively whether the user has requested it or not. That should give us what we want effectively. And it's towards the end where normally, so there's already a restart here. We can see reboot the container. So this is done at the end of that hook. And we effectively want to do the same thing, except that, we will want the instance restarted, we'll want all of that logic. But we need to check here whether we should be auto restarting the instance. So target reboot or auto restart. So then we need to populate the auto restart key with effectively the result of our check. So the most basic check we do is let's do determine if instance should be auto restarted. Okay, so we'll start with just the variable step. So auto restart as a boolean, so it will be set to false by default. And then what we want to check is so if op d.op, so if there's no operation, because if there's an operation, it means the user requested it. So if the user requested it, we don't want to auto restart. So yeah, if there's no pending operation for the startup or restart of the instance, and we have in the config key is set to true, so that's the util is true for the instance. Then we'll pull the config key, so expanded config, and we want to look specifically at the new config key, so boot.auto restart. Okay. So in this scenario, we're just gonna set auto restart to true. And that doesn't include any of the backup logic, effectively. It just, is the config key set? Yes. Did the user ask for it to be stopped? No. Okay, fine, start it back up. That's basically what this does. So let's just build this and make sure it works. But that's kind of the most basic. Then we'll need to try being a bit more smart and keep track of, okay, when was the instance restarted for the last time, effectively. and figuring out whether whether we've been restarting it too much already. Okay. So this has been built. Now move the binary in place. And I think what I'll do is here put the monitor in place and look at the lifecycle events. Okay, we'll just try a few simple things on that instance first to make sure things behave. So if we stop it normally, failed restarting instance already running. Okay, well, that's not a good sign. Okay, now it's stopped, fine. Okay, it started, it's good. If we ask for it to be restarted, it's still failing with status is running. Why? What's going on here? Like I've not done anything too interesting yet. Oh, well, yeah, the logic is backwards, so that's good. Let me go and fix that. So it's definitely, we only want to turn on the auto restart if there is no operation, so if there's no user request. So that's why it's all messed up. It's because this is literally backwards. Okay, that should fix it. Okay, restart this thing. Okay, instance is running, good. Normal user requested stop, worked fine. User requested start, worked fine. User requested restart, worked fine. Instance requested restart, shutdown restarted. Okay, the shutdown thing is a bit unfortunate. We need to see if we can get rid of that, but that's fine. And it doesn't show a requester because it was triggered by the instance, so that's fine. And now if the instance turns off, instance shutdown, this did a clean shutdown, which is not good. This one I would have expected to restart. Okay, instance started. Let me check. So we're gonna go and actually kill it. Let's see if that triggers something different. Actually, we want the init system within it to die, not the monitor. Okay, so 1879759. Okay, shut down. So that didn't trigger a restart. Now, why? So I guess the operation is set, which is not good. So we probably initialize an operation by ourselves, so I can't easily tell if it's user requested or not because of that. Let's see what's going on exactly. Yeah. Oh, yeah, up here. Set operation if missing. Okay, so that's a problem. That will be easy enough to fix, but that's the problem. Okay. Just checking what we do otherwise. Okay. Cool. That basically means the logic itself. So whether we need to auto restart, that logic needs to go earlier before we override the operation path. So effectively here, the domain of instance should be restarted. And at that point, we'll only have no if this is not a user requested action, and then we'll just auto restart. Okay, let's try that. Okay. And I'll just put this in place. again. Here we go. Okay, and let's look at this and just go through the tests again. So, got an stopped instance. Fine. Start it. Looks good. Restart it. Doesn't look good. Okay. Why? Like we got the error saying this instance is running, which we should not be getting. Gonna need to put some debugging in there because that doesn't make sense. Like if the user requests it, we should have this. Let me just check, what do we pass to this function? Detail it up. Okay. Now we pass the operation as the last argument. Okay. What's going on exactly here? Okay. So there's just an issue with like the way this operation stuff works here. In here we do on-stop operation setup. Let's see what that does in Knife. Okay, this is probably a common piece of logic then. On-stop up. Operation setup, yeah, there we go. So it tries to see if there is an operation going on the instance. And if it is, what type of operation is going on. Okay. So if there is, okay, it's gonna read in the scenario waiting for existing operation. Okay, so if there's anything other than what we expect, we're waiting for it to complete. Okay. Then if the operation is not one we expect, then we start, then we replace the, or initialize a new operation effectively. And we return that operation. Okay. So this call will always return an operation effectively. Okay, so we effectively need some result, some version of this check, or we need that function to give us a tiny bit more context. Okay, just checking something. So there's a set instance initiated, which is set. So that means whether effectively if we can check this value, then we can tell if it's if the user requested it or not. And let me check that logic. There's an operation log here. Sets instance initiated, sets this thing, and we can do get instance initiated. Okay, cool. So that's what we should do in here then. Going back here, this logic is actually fine. Oops. Oh, come on. Okay. There we go. Just going back to where we restarted. Determine if instance should be auto restarted. d.up dot get instance initiated. So if it's instance initiated and we've got the boolean set to true, then we go and restart. Otherwise, it's user initiated and we don't touch it. So hopefully that actually works. Undefined operations, that operation has no field. Okay, so it's because we want up instead of d.up. Okay. Got too many things that are called operation within the Incas code base. That's actually causing some issues occasionally. Okay, here, so that's the unstop, and down there we want up, not d.up. There we go. Okay, that's looking better. Right. So let's go through the motions again. Stop it to begin with. That worked. So clean shutdown. Then starting it works. Restarting it works. And if I go inside it and I trigger restart from inside, shutdown restarted. Okay. And now shut it down from there. We get shut down, but we didn't get a start. So that's a problem. It's as if it doesn't have the instance initiated flag set, which feels wrong then. What's going on? Just checking. Boot auto restart is set to true. So that should have worked. Gonna go look at this again. And just put some debugging because I'm getting tired of this. So I want to dump everything that's related to the operation, and I just want to dump the config too. There we go. So on the operation and expanded config, please. Like, I don't know why the instance initiated flag wouldn't be set, but apparently it's not. So let's go see. Right. Let's start that instance again. Go in there, and then I'll turn it off. I mean, it could be that this actually does two cleaner shutdown, maybe. I don't know. Here we go. So details. We've got a stop operation going. Its instance initiated is true. Okay. So we do have that flag set to true, as expected. And boot auto restart is true. Okay, so that should have led to the correct value. But then it didn't. Doesn't really make sense. Yeah, it still stopped. Okay. All right. If target reboot, auto restart, start the container again. Okay. Was there a typo in there? That would be the easiest explanation for that. But that looks correct. I should actually dump the auto restart value too. One of those cases was going to be something extremely simple. That's wrong, but let's see. Okay. Restart this thing. Okay, result is true. I actually do see started. So what the hell? Why didn't it actually restart then? So if I do a reboot, that does work, doesn't it? Yeah, that does. So what's different? Because in this case, it did shutdown instance, so we got the event and then started. So that worked properly. But then in this run, we had shut down the instance. Oh, failed restarting instance. The instance already running. Okay. No, it's not. that doesn't make too much sense. I don't understand why one is different from the other in this scenario. It's literally the same code path. So what's going on here? So we do see the shutdown is emitted at this point. That's fine. Then we check if it's instantiated. We set the restart flag, and then we treat it as if the instance told us that it's a user reboot, which should then be fine. Is there something else we do in a reboot case that I'm missing in here? Not really. So we get the target, obviously. Target, stop reboot, check it there. Okay, so the unstop operation. Oh, maybe that's the issue. Interesting. So basically what's going on here is when we call unstop operation, we tell it what we want to do, whether we want to stop it or to reboot it. And in this case, we're currently passing stop instead of reboot, because we don't know yet. So I wonder if that's the issue. Is that causing other problems with like the kind of operations that are allowed? Because I suspect what's going on is that when we call start allows reusing a restart operation. It does not allow reusing a stop operation, which is why it's failing. So that's a bit of a weird scenario here. I don't remember if there's a way to convert an operation in place from one type to another, because what we kind of want is just before, like in the restart case, effectively turn the operation into a restart one, so that we can then proceed with the restart. So operation lock, what are the functions can we do on there? Creation, obviously, get, okay. So that's the action match, wait, done. We could mark it as done and then start again. That's could be a bit of a hack. Get operation, get instance initiated. Okay. I thought there was a way to convert one effectively. Is it one of the create ones? So create wait get, that's a bit of a weird one. I think it's create and you effectively do a reuse on it. So we can call create and then project name, instance name, the API operation, there wouldn't be one in this scenario. Then the action you want, and reusable, reuse existing. And if we do reuse existing, so it will look if there's an existing one. If it's reusable and reuse existing, then we just go and pull the existing operation, but it doesn't change the type, which is not quite what we want. Otherwise we fail with busy. Okay. I wonder what actually ends up calling done on that operation then. Is it on code? If it is, then we can call it done and just issue a restart operation. Let's see. Trigger rebalance. Like here it calls failed restarting. Okay, fine. But where do we actually do the done call for success? Is there a defer? There is. Defer up, done. Okay. All right, so that's what's going on here. Cool. So let's just complete the current operation and then that will allow it to be started back, effectively clear of any operation, and that will fix that. We should probably put an extra condition here. So we don't want to trigger this if we're already rebooting. Okay, and then if we are, we'll set the auto restart, and then we'll consider the shutdown to be completed. Mark current shutdown as complete, which then allows us to issue a start operation. That should fix things. So up.done. And up.done can be called multiple times. It's safe, so that's fine. And anyway, here we're not, we're literally just returning. And it's only in the error case that we call up.done again. Okay, so that should be okay, I think. Let's go and try that. And we've got a lot of that kind of locking and stuff going on, because obviously there can be multiple tools interacting with a given instance. Like you might be pulling files, executing stuff at the same time someone is trying to reboot. So we're keeping track of all of that through locks to make it so we effectively wait for pending operations to complete before we go and restart anything or stop anything. So that's what's going on. I just need to get those pieces correct. All right, so now let's go look. Actually, I should be able to switch back to just the lifecycle stuff. Yeah. Okay, so we've got an instance. Let's try to just restart it. Okay, restarted is fine. If it self restarts, shutdown restarted is fine. If we cleanly stop it, shutdown, okay. Cleanly start it back, good. And then if it exits for some reason, shutdown started, restarted. Okay, well, the status is a bit weird, but the result is correct. So the instance triggered a shutdown, which then converted that to started, which then caused it to be flagged as restarted. So there might be some cleanup to do around the lifecycle logic, but at least it did come back up. So that was the goal. Now, I'm actually, like, one of the questions I've got is why does this case do shutdown and restarted? And whether we can fix that, because that would probably fix the other thing we're seeing. So life cycle shutdown. No. Is it life cycle like that? Shutdown. Yeah. Okay. So we do it in two different spots. Which spot is that now? Shutdown. Okay, that's what's called by the user doing a normal stop. So it's not this code path we're seeing. We're definitely seeing this code path here. Which means, yeah, it is instance initiated, but it's actually a restart. So we shouldn't log shutdown if we're dealing with a restart. So actually we should just check for stop, I think. Okay. So if we're being, no, actually I think the not equal is safer. So if this is not a reboot, we should not log shutdown. Let's do that and see how that looks. So that should clear the calling reboot inside the instance as far as the lifecycle events. And lifecycle events are pretty useful for anyone who's not dealt with them much. They effectively provide an audit trail of everything that's going on with Ingress, including who's requested what. So that's why when you see me do it from the command line, you can see exactly who has been sending that request through. If it's the container itself, then you don't have that information. Obviously, it makes sense. We might put some annotation down the line to actually say this was like actually initiated by the container, or this was initiated by Incus internally, or showing those kind of options. Anyway, it should, I think I built it, I updated it, so it should be okay. Exec C1 reboot. Yep, exec restarted. Okay, so we're good now. Just make sure the rest is fine. Stop is good. Start is good. User initiated restart is good. Okay. And then let's try the container initiated one. So still shutdown started, restarted. So that's still a bit awkward. So that one is effectively separate logic, which makes sense. Like the target in this case would not be reboot. The target would be stop. So we would go and log this thing, which does the shutdown. And then we would go and call start, which failing a restart operation is gonna be going straight to logging start, and then this will log restarted. So I think the way to deal with this is actually move this logic a tiny bit. Oops. Okay, fine. Move that down here. Can remove this debugging here. It's not needed anymore. And then this one. So if not reboot and not auto restart and user initiated instance initiated, then log shutdown. Okay, that's fine. And here, so we've got up.done, so the operation is marked as done at that stage. What we should do is actually set up a new restart operation, which will then silence the start restarted thing. I just need to remember how to do that now. Operation lock, create something. Something like that, yeah. Now I want the restart one. Okay, so when we do an actual user restart, where's that? It doesn't really exist, does it? Yeah, it doesn't really. Okay. Well, we'll just use this one, that's fine. Okay. Destroy. Okay. Restart. So that's where we need to set this thing. Here we go. So operation, we're going to be overriding it, and project name, instance name, any existing operation we have, sure. I mean, there shouldn't be any, but okay. Then the action itself is going to be a restart at that point. And then we allow a number of existing operations as far as what we take, as far as what we could in theory take over. But in this case, we're going to go with nothing. I'm confused. What am I doing? Okay, it's all of the operations we support taking over from, so none of that. And then there's whether this can be, this allows reusing, and whether, so there's the reuse. Yeah, it's whether we want to reuse or, well, if we want to make it reusable, and or if we want to reuse. So it should be reusable, but we don't want to reuse effectively. So that's the logic here. And then, so if this fails, then effectively return, because there's not much we can do at that stage. There's no operation we can really mark as failed or anything. We just return. What do we do up here? Do we log something if that fails? Yeah, we'll probably do. Sentinel request target. Oh, so this one actually returns an error because it can. We should probably just log something. Yeah. Okay. I'm actually tempted to just not fail it because it's not really critical. Failed to set up new restart operation. I'll just do this. Okay. That should be okay, I think. Let's see. Oh, actually, I missed something because doing this, nothing is gonna actually complete the operation, so it's gonna stay in restarted state, which is not good. So we need to actually go and effectively, if we're good, actually no, we'll do if we're clear. We'll do up dot done as the defer and else log the error. Okay. So that should do the right logic. Let's see if that all works. Gonna do the old check again to make sure that we're getting expected events for everything. Okay. So just stop the instance. That worked. Clean shutdown. Start the instance. We can do a force shutdown just for like a force stop. Should be instance stopped. Yeah, we're good. Still good. A normal user restart. Restarted. Good. And then instance initiated restart. We're good. And now instance initiated shutdown. Restarted. Okay, perfect. And just to make sure, let's do a normal user restart afterwards to make sure the logs got released. Yeah, we're good. Excellent. So now let's check an actual crash case to make sure this works properly. So I'm gonna go and kill the init system in that instance to kind of simulate what you get in an application container. And restart it. Perfect. Exactly what we want to see. So that's all good there. Now we're gonna go apply the same logic on the VM side, and then the back-off logic can effectively come afterwards and be shared between both implementations. So I'm just gonna go look at QEMU next, and then the generic logic will be added. So let's just go look at the code we have so far. So that's the actual restart logic that was added. There is a fix in there, which is here. It's kind of mixed in, but effectively that fixes the other issue with the lifecycle events being wrong. So let's just commit that as incust instance drivers xc implement boot.auto restart. Okay, and we'll actually copy paste most of that logic and hope that this looks very similar on the QEMU side. I don't actually remember. So we just need a new instance. So just a VM, source image. What do I have in this profile here? Must have something weird. Yeah, I do. Okay. Sure, whatever. Seriously? Oh, it's because the project is restricted. Hold on. I mean, that's fine, but it's because I was doing testing on a restricted project. So if I bump that to 10 gigs, it should be fine. Assuming I'm not out of quota. That's the project I used, I think, in the release announcement for 6.4, where I showed the different limits per storage pools. So that's what that was used for. Okay, so VM. Let's just try the initial behavior, make sure everything makes sense. So we can see here we've got started. Let's see if the VM is functional. It is, so we've got exec, it's fine. Then clean shutdown. Shutdown is good. Takes a bit longer with the VM because we need to wait for it to be booted, which takes like, about 10 seconds or something. That's why I'm doing exec every time to just make sure it's functional. It is. So we saw start stop is fine. Let's do a normal restart. And that blew up, not sure why. What happened with that VM? Cannot initialize fsdev config failed to open. Okay, sure. Why? Anyway, that's weird. Let's try it again, maybe. Let's see, QEMU error. Value Beancast devices, demo v1, config.mount. Okay, I don't know why that would have failed, but sure. Definitely unrelated, we haven't done anything with it yet, but that's not very encouraging, because if there's that issue in the way, I won't be able to actually test any of this stuff. Anyway, let's try the other cases. So VM initiated shutdown, that works, okay. And we'll do VM initiated reboot, see if that works. But there's clearly an issue with some device cleanup in shutdown while doing a user requested restart, which is going to be a problem if that's in the way. So I need to fix that first. Okay, so that's kind of weird. Anyway, VM restart. So yeah, shutdown restarted. Okay, so when it's self-initiated, it's fine. When it's user-initiated, it's not. So that's kind of backwards. It usually doesn't happen that way. Okay. So let's go look at that logic, see if we can figure it out quickly. Does it have a unstop function too? It does, okay. So we see unstop hook started, finished, okay. It does the same operation, upgrade thing. It releases everything at the end. Okay, so it looks very similar, which is good. I just don't know why the restart didn't work. So let me actually do, like I said, like I need to sort that one first, otherwise we're gonna have a problem when we automatically trigger it. So let's do a restart again on that VM and just see what's going on. So if I do restart, are you kidding me? I hate races. Why are we getting a race condition on this one? It's gonna make testing very frustrating. Okay. Oh, something failed in the background. Failed to stop device. Failed clearing net prior rule, for instance. Device name is empty. Okay. Yeah, there's something wonky going on with devices. Okay. Because we can see... Okay, let me actually just clear that terminal, do a restart and see exactly what we get. Yeah, well, it's just not failing anymore, so that's kind of frustrating. Okay, API request, show sending the request. So 1.0 to connect to the API, connecting to the events endpoint, asking for the restart. Instance operation log created, so we create the restart request from the user. That creates a new operation in the API. Starting operation, restarting instance, okay. Action shutdown, sure. Shutdown started. Hook inherited, instance stop. Okay, there we go. Unstop hook started. Start started, instance operation, stopping device. So there's probably something wrong going on around here, that'd be my guess. Which kind of races with itself and causes the issue. But it's not failing anymore, so that's not super good to debug it. What we'll do for now is just replicate the changes from the LXC side into QEMU and see how that works, I guess. So I'm going to get my changes down here, and then we'll go and look at the other unstop. I said the syntax is very similar, so that's convenient. This is the logic being hit when the user requests, triggers a shutdown from within the VM. Presumably also if QEMU gets killed for some reason, but I need to make sure that this works. So unlocking, stop operation if missing, that's fine. And Okay, so it's a device cleanup, which is potentially what's causing us some issues, but okay. Unmounting the instance, cleaning up all the stuff, and then that's the reboot logic. So very, very similar, which is good. It's kind of what we want to see. So let's do auto restart on this guy. And I trying to remember, I think when I was doing it instance initiated, we were getting the correct life cycles, but I'm not sure anymore. So let me just recheck this one. So if I do a reboot from inside the VM, nope, shut down, restarted. Okay, so we've got the exact same bug. So let's go and fix that one first. So if target is not reboot, and I think the actual logic was slightly more complex than this because we're doing target not reboot and not auto restart and this, then we go ahead and log instance shutdown. Otherwise, if it's a migration, sure, we do stop. That's fine, never mind. We're gonna put the same logic here and potentially just tweak it a bit, but maybe not even. Like a bunch of that code is thankfully shared, but a bunch of it is not. This is definitely a piece where it's not really. So target not reboot, or get instance initiated, but restart. That should work. We replace the operation. Failed to set up new operation. Okay, so that should be fine. And then we've changed this one already, and we've changed the other one. So it's effectively exactly the same change. Let's see if that works. Okay, auto restart is not set. What did I miss? 658. We put the instance. Did I typo something? Yeah, I did. Okay. Cool. And that VM currently doesn't have the auto restart flag on, so we can just check that behavior real quick. Just something I've not done on the container side, but by testing the same logic on the VM, it will do just fine. So reconnecting. Okay. And then if I go in the VM and we do power off, it just does a shutdown. Good. And now if I set v1 boot.auto restart true and start the VM back up, this time doing the shutdown should cause it to at least attempt to restart. We'll see if it hits the same bug as earlier. Okay, so shutdown, stopped, restarted. Okay, why stopped then? We shouldn't have seen stopped. Okay. That's still not the one. How many of that same logic do we have in this thing? This is an actual stop. I'm so confused. Okay, we just have 2 of that code path. Oh, I'm looking at the wrong file. Well, that's fine. I want QEMU, not LXC. There we go. Oh, if up action, not operation, action migrate. Okay, so that's the issue. Okay, so we just need to do another auto restart here. Just so we don't log it in the auto restart case, and we should be fine. That logic is slightly different. I think it's kind of related to live migration, which is not as much of a thing in containers. So that's why QEMU is a bit different on that code path. Okay, let's try it again. On the upside, we did see, well, we did see the expected behavior, so that's good. And now VM is running, v1 power off. Cool, and restarted. Nice. So that worked properly. Next up is gonna be testing this by doing just a basic kill of QEMU, seeing if it correctly restarts on a crash, because I don't know if that hook is actually called during a crash. So let's see, 1919490, and go. Restarted. Sweet. Okay, so that works perfectly. We've got the config key, we've got the QEMU logic, but the LXC logic. It's nice. Let's commit that for QEMU. And the only thing that's really needed to put now is some kind of shared backoff type logic, which I'll probably put in driver common so that both LXC and QEMU can pull that and run it. Like, again, we don't want to cause too much duplicated logic. So effectively in this check here, there's going to be an additional check of whether it should actually trigger the restart based on like, you know, how many times was it restarted within the past minute, effectively. And that should be it. Not sure what's going on with chat here. That's not good. Okay. And I think that's gonna be it for this live stream. I'm gonna do some of that cleanup after the fact and send a PR probably in the next couple hours. So it's literally just kind of that kind of, you know, backoff logic that needs to be added. I said gonna keep it pretty simple. I'm just gonna look at number of restarts within the past minute and just call that done. We'll see. I think I might be able to just do like effectively a ring of timestamps so that we can easily check the past X entries, look at each of the timestamps. If any of them are within the past minute, then just consider that this is not okay, and move on. So that's the idea. Hopefully this was useful. I mean, you can go look at the actual resulting stuff commits for anyone who wants to do feature development on Incus. That's kind of what that looks like. One commit to actually add the API extensions, it's just text. One commit to add the new config key, one auto-generated commit for the documentation and API definition, and then implementation of the logic in both the LXC and QEMU drivers. And that pretty much is it. There is like there's going to be a tiny bit more where like I want to put the backoff logic in and then write an extra change to add a test, which will be done on containers. So effectively start the container, get the process ID for that container. So if I do C1 and then look for PID, getting that value and then sending a kill signal to it and seeing whether the instance comes back. So it's effectively kind of like this. And we can see it's coming back to life and we're back online. So just writing a tiny test that will do exactly this. And ideally another test which just does this, but like, you know, 6 times in a row and make sure it doesn't come back online. Just make sure that the backoff type logic is functional. And yeah, that's it for this one. Hopefully this was useful. If you got any questions on this or the Incus questions, feel free to leave them down in the comment section below, and or go on the forum. And there's a question whether this is also working for app containers. Yeah, it's the exact same logic. Let me I can actually just show that. What do I have that we can easily run? Is it Nginx for one of them, I guess? But it works the exact same way, where we effectively use the LXC runtime in both cases with the exact same events, the exact same everything. There's no separate driver for application containers. So this is going to work the exact same way. And this is actually where it's going to be the most useful. It's just kind of easier for me to work with normal system containers because I can install tools, I can see exactly what they're doing a bit easier than application containers. But in this case, here we go. We've got the Nginx container running. If I just go and do the same PID trick for it, it's gonna die and not come back. It's dead. And oops. And now if I start it back up and set the new config key on it, put auto restart true, and then we go and make it crash again. It's back up, and again, and we can actually see, just to make sure this actually works. The init system for that container is ID 192 something something 671. Try it again, and it's a different number, so it did get restarted. So yeah, exactly the same logic, and probably where it's going to be most useful, because system containers and virtual machines don't really crash that badly very often, but application containers do, so that's where it's going to be most useful. One thing I kind of touched on that's probably worth mentioning again is we don't currently have a good way to detect an exit code from a container or even a virtual machine. So it's hard for us to tell whether this was an intentional shutdown or not. That's why I actually did that testing by literally running a clean shutdown with power off from inside the container or VM, and it came back online. This is something we'll want to change, I think, down the line once we have reliable exit codes coming out of both the QEMU and the LXC drivers, so that we don't actually restart a legitimate clean shutdown request by the user, but we restart on failures only. So that's the idea. It's not currently possible, so that's why the logic will technically cover both. But I've phrased the documentation in a way that suggests we specifically want to do it on failure, so that we can fix the rest of the logic down the line and just make it only happen on actual failures, and not really surprise anyone when we actually fix this. So again, that's it for this one. Feel free to leave comments down in the comment section or on the forum. Next video is gonna be a release announcement for Incus 6.5, so that's gonna be coming out on Friday next week. And then I'm gonna be traveling for a couple of weeks. So I've got 1 week with customers in Europe, where I probably won't be able to do any kind of live streaming or anything. And then the week after that, I'm gonna be at the Linux Plumbers Conference, a Linux Kernel Summit in Vienna, where again, I'm not gonna be doing any kind of live streaming or videos from there. So there's gonna be a 2 weeks break, and then I'll be back and probably will do a live stream effectively the week I'm back home. And yeah, that's it for this one. Thanks a lot for watching, and I'll see you in that release video next week. Yep. And just finding what chat and stuff is. There we go. Thanks a lot. Bye.